Good morning guys. In today's class we'll be seeing a topic on integrals named as indefinite integrals. Here we'll be having two concepts. One is indefinite integral and definite integral. The subtopic is indefinite integral. Here we should know what do you mean by this particular integration. Integral is nothing but an antiderivative. Integral is nothing but an antiderivative. Before starting the problem, I'll be giving up some formulas, and after learning up some formulas, we'll be knowing its particular application. So, the very first formula, integral of x power n dx, that is equal to x power n plus 1 by n plus 1 plus c. We go by an example of this. If suppose anytime you come across x cube dx, in place of n we are having 3, so we can write it as x power 3 plus 1 by 3 plus 1 plus c, and the net result will be x power 4 by 4 plus c. So finally what can I tell? X cube dx means x power 4 by 4 plus c. Now I am going for another formula. If suppose formula e power integral of e power x dx is there, the formula will be e power dx plus c. And sometimes in your textbooks you will be coming across e power ax dx. Whenever this kind of notation is coming, always observe carefully, the coefficient of x over here is a, and that should come as an denominator. But in differentiation what we used to do, we used to write a as in terms of product. But here what we will be doing means e power ax by a plus c. So for this I will give an example. Integral of e power 2x dx is given to you. So finally what happens here? E power 2x by 2 plus c. I think it is clear to you. Integral of e power ax dx means here I had written as e power ax by a, and I said coefficient of x is a, that comes as denominator, and here c you call as a constant of integration. Therefore integral of e power 2x dx means we should write as e power 2x by 2 plus c. I think you are clear with these two formulas, two basic algebraic integration formulas. Integral of x power n dx is nothing but x power n plus 1 by n plus 1 plus c, and integral of e power x dx is equal to e power x dx plus c. And finally remember, whatever coefficient of x is there in integral formulas, that comes as in terms of denominator. That term particularly comes in terms of denominator. So later we'll be learning another formula. Now integral of 1 by x dx is always written as log mod x plus c. But in differentiation what happens? How we used to write? D by dx of log x. D by dx of log x means we used to write as 1 by x. But I said integration is and quite opposite to differentiation. So integral of 1 by x dx, that means whatever result we get while doing differentiation, to that result if we integrate we will be getting the final output. Next, another formula we shall be seeing, integral of k into dx. That means here k is some constant, that k will be coming outside, and there remains integral of dx, and finally our answer will be k into x plus c. Another formula. Now we shall be seeing some basic trigonometric integration formulas. So integral of sin x dx is nothing but minus cos x plus c. Next, integral of cos x dx will always be sin x plus c. Later, integral of, if suppose another function will be there, sin will be there, cos will be there, but we will be learning tan also. Tan will be learned by another method called as substitution method, but only we are learning today now basic things. Now what happens later? Integral of secant x tan x dx. Integral of secant x tan x dx will be always secant x plus c. And later again integral of cosecant x cot x, cosecant x, integral of cosecant x cot x dx. Integral of cosecant x cot x dx means always we should write as minus cosecant x plus c. Now if you could observe carefully, we need to remember all these 8 kind of formulas. The very first one is x power n dx is equal to x power n plus 1 by n plus 1 plus c, and integral of e power x dx is equal to e power x dx plus c, and integral of 1 by x dx is log mod x plus c, and the integral of k into dx is nothing but kx plus c, and integral of sin x dx is minus cos x plus c, and integral of cos x is equal to sin x plus c, integral of secant x tan x is equal to secant x plus c, integral of cosecant x cot x is minus cosecant x plus c. So I think now you are well aware of the basic 8 formulas. Now we'll be seeing algebraic properties of integrals. For doing the problems, for doing the numerical problems, all these are very, very useful. Algebraic properties of integrals. What these algebraic properties are telling, you can observe carefully now. Integral of k into f of x dx. That means constant multiplied by the function. Constant multiplied by the function. So what happens? This particular k comes outside. K is always a constant, and integral of f of x dx. So I go by an example. If suppose a problem is given to you, integral of 2 sin x dx. Integral of 2 sin x dx is given. So what happens? 2 will be coming outside, and integral of sin x dx will be coming, and 2 into integral of sin x means what? Minus cos x plus c. So finally our output will be minus 2 cos x plus c. So finally how can I write? Integral of 2 sin x dx. 2 sin x dx is nothing but minus 2 cos x plus c. So we learned an important property. Integral of k into f of x dx is equal to k into integral of f of x dx. Now if suppose another property is there like this. Integral of k1 into f of x plus or minus k2 into f2 of x dx is given to us. So how we will be writing means integral of k1 into f of x, or I will write as f1 of x plus nothing written means here it is clearly understood dx, plus integral of k2 into f2 of x dx. And now I think I can apply this particular property here. So what happens here? K1 is a constant, and k1 will be coming outside, and finally there remains k1 into f1 of x dx plus k2 into f2 of x dx. So friends, we learned now 8 formulas. After finishing 8 formulas, we learned 2 basic algebraic properties of integrals. Now we'll be starting with our numerical problems. Now basing upon our integral properties, we shall see a small problem where we can apply those integral properties. If you could observe carefully, a big function is given to you. It is looking like giant, but it is not actually a giant function. It's a very, very chota function. 4x cube plus 3x square plus 2x plus 4 dx. इसको हम I'll be calling this as f1, this as f2, and this as f3, and this as f4. This I'll be calling it as f1. And outside, if you could observe carefully, there is a symbol called integral. And in between there is symbol algebraic operation called as plus. Whenever plus or minus is there, we need to divide or we need to segregate, and we need to apply this particular integral. So what happens? Integral of 4x cube dx plus integral of 3x square dx plus integral of 2x dx plus integral of 4 dx. Now again, if you could observe carefully, here this particular 4 can be coming outside, because earlier I said a property, integral of k into f of x dx is nothing but k into integral of f of x dx. So what happens? 4 into integral of x cube dx plus 3 into integral of x square dx plus 2 into integral of x dx plus 4 into integral of dx. So again, if you could observe carefully, it is like integral of x power n dx. So what happens? Integral of x power n dx means x power n plus 1 by n plus 1 plus c. So what happens? X power 3 plus 1 by 3 plus 1 plus 3 into x power 2 plus 1 by 2 plus 1 plus 2 into x power 1 plus 1 by 1 plus 1 plus 4 into integral of dx. Integral of dx means 4x. But in formulas what we said, integral of x power n dx is nothing but x power n plus 1 by n plus 1 plus c. But if you could observe carefully, here c, here c, here c, here c, we won't be writing. Finally, we'll be keeping only one c. So what happens finally? Here I think 4 4 will be getting cancelled. Here 3 3 will be getting cancelled, and here 2 2 will be getting cancelled. Finally, there remains x power 4 plus x cube plus x square plus 4x, and I'll be putting on the whole as one big C. So finally what happened? Integral of 4x cube plus 3x square plus 2x plus 4 is nothing but x power 4 plus x cube plus x square plus 4x plus c. I think the very first problem is very clear to you. Now I'll be going in a little better depth of this particular integral problem. Now we try to solve this particular problem. I think it's an example problem. Integral of x power 4 plus 5x square plus 3 by root x dx. If you could observe carefully here, A, I will consider this as B, I consider this as C, and I consider this as D. So in our lower classes, in ratio and proportion, we learned a concept. If A plus B plus C by D is given means, it can be written as A by D plus B by D plus C by D. The same technique we will be applying over here. So how it comes means x power 4 by root x dx plus 5x square by root x dx plus 3 by root x dx. Finally, if you could observe carefully, I think I can apply total integration now. Why? Because algebraic properties, I think you are clear. X power 4 by root x dx, 5x square by root x dx, 3 by root x dx, I can apply integrals individually because of the algebraic properties of integrals. Now before applying the integral, if you could observe carefully, it is looking like x power m by x power n. Here m की जगह में 4 और n की जगह में 1 by 2. So finally what I will be doing means x power 4 minus 1 by 2, x power 4 minus 1 by 2 dx. Why? Because x power m by x power n means x power m minus n. And now here also 5 I will be taking outside. Finally what happens? X square x power 2 minus 1 by 2 dx. I think it is clear to you because it is like x power m by x power n. So x power m minus n plus again here 3 will be coming outside, and here what happens? X power minus 1 by 2 dx. Now if you could observe carefully, this is looking like x power 7 by 2 because 4 minus 1 by 2 LCM. I need not explain all these basics now. So 5 into here also x power 3 by 2 dx, and here 3 into integral of x power minus 1 by 2 dx. And now again our basic formula comes, it is like x power n dx. X power n dx means x power n plus 1 by n plus 1. So x power 7 by 2 plus 1 by 7 by 2 plus 1 plus 5 into x power 3 by 2 plus 1 by 3 by 2, 3 by 2 plus 1 plus 3 into Here again it goes as x power minus 1 by 2 plus 1 by minus 1 by 2 plus 1 plus c. I think now you can do this particular calculation, and I'll be writing there the answer finally. X power 7 by 2 plus 1, 7 by 2 plus 1 means it is 9 by 2, and denominator also 9 by 2, going up means 2 by 9. So what happens? 2 by 9 x power 9 by 2 plus, again if you could observe carefully, here 5 is there and here 3 by 2 plus 1, 3 by 2 plus 1 means 5 by 2. So what happens? 5 into 2 by 5, and here x power 5 by 2. Finally here also 3 is there, and minus 1 by 2 plus 1 means half. So what happens? 3 into half going up means it turns down to 2, and here x power 1 by 2. Finally I will write here plus c. So finally we will be manipulating and telling the answer. 5 will be getting cancelled here. So 2 by 9 x power 9 by 2 plus 2 into x power 5 by 2 plus 6 x power 1 by 2 plus c. Up till now we had seen some problems based on application of integral in with respect to algebraic function. Now और थोड़ा level बढ़ जाएंगे. We'll be doing application of trigonometric functions, and we need to remember the formulas. At the beginning of the class only I said the formulas, right? Now here there are two problems. The very first problem we'll be looking up: integral of sin cube x plus cos cube x divided by sin square x cos square x dx. Now again the same concept here, a plus b by c. So it comes as a by c plus b by c. So finally what happens? That is equal to, I'll be writing it as sin cube x divided by sin square x cos square x dx plus again integral of cos cube x divided by sin square x and cos square x dx. Now if you could observe carefully, here sin cube x is there and here sin square x is there. I think blindly I can cancel one sin square x, and finally there remains here sin x. Now again if you could observe carefully, here also one cos square x and here cos square x gets cancelled, there remains cos x. So finally what happens? There remains integral of sin x by cos square x can be written as cos x, and another cos x I will be writing it as 1 by cos x dx. I think it is clear, because cos x into cos x is cos square x. Similarly here also cos x divided by sin x, and here again 1 by sin x dx. Now I think it is clear, sin x into sin x is sin square x. So finally it reduces to sin x by cos x is nothing but tan x, and 1 by cos x is nothing but secant x dx, and here also cos x by sin x is nothing but cot x, 1 by sin x is nothing but cosecant x dx. So friends, now again we got our formula. We should remember the basic formula. Integral of secant x tan x is always secant x, and integral of cot x cosecant x is always nothing but minus cosecant x, finally plus c. So once again I will be repeating the problem. Integral of sin cube x plus cos cube x divided by sin square x cos square x. It is like a plus b by c. A plus b by c means a by c plus b by c. So what happened? Sin cube x divided by sin square x into cos square x. One sin square x is getting cancelled, so there remains sin x, and here also cos square x is getting cancelled, there remains cos x. So finally what happening? Sin x by cos x into 1 by cos x dx plus cos x by sin x into 1 by sin x dx. Now sin x by cos x is nothing but tan x, 1 by cos x is nothing but secant x. Cos x by sin x is cot x, 1 by sin x is nothing but cosecant x. So integral of tan x secant x will be secant x, and integral of cot x cosecant x will be minus cosecant x plus c. Now I will be going for another problem. integral of 1 minus sin x by cos square x dx. Very beautiful problem. It is also looking like a minus b by c, so I can make it as a by c minus b by c. So here what happens, integral of 1 by cos square x dx minus integral of sin x by cos square x is there, so cos square x I'll be writing as 1 by cos x, can I write like this, sin x by cos x into 1 by cos x dx. So if you could observe carefully, 1 by cos square x is nothing but secant square x dx, it's a secant square x dx minus, here also sin x by cos x means what beta, tan x, and 1 by cos x is nothing but secant x dx. So again our formula is coming, integral of secant square x, integral of secant square is nothing but tan x, and integral of tan x secant is nothing but secant x plus c. So in today's class we learned about application of integral with respect to algebraic function and application of integral in trigonometric function. Right friends, in previous class we had seen some basic integration concepts and application of integration with respect to algebraic function and in trigonometric function. Now we shall go for a little bit higher level. There are various methods of doing integration. The very first one we call as a transformation, integration by transformation, and next number 2 substitution method, number 3 by parts, and number 4 partial fractions. Right, in today's class we will be seeing 2 to 3 examples based on this particular transformation. I will be taking 2 to 3 problems and remaining problems I give as a worksheet.